before we start solving this differential equation, let's start by writing down the Taylor series expansion. Now, the Taylor series expansion is given below, and this is available in your formula booklets. F of x is equal to fa plus x minus a f dash a plus x minus a squared over 2 factorial and this goes to infinity. So here we are given the boundary condition, and that should be able to give us the first coefficient. So step 1 is find the coefficients. Okay, now these are the coefficients that I'm talking about. These guys here. Now this one is actually already given here. All right, so we can start with that. F1 is equal to 0. That's already given. So what we need to do now is to find the value of the first derivative at x is equals to 1 and y is equals to 0. So we can actually do that by plugging in those values into the differential equation. So that will be 1 squared plus 0 squared, which will be equal to 1. Also need to find the second derivative. And to find the second derivative, we just need to differentiate the first derivative. And this will be equal to we have to differentiate this term by term. What we shall end up with is 2x plus 2y dy over dx. So the value of the second derivative at x is equals to 1 and y is equals to 0 will be equal to 2 multiplied by 1 plus 2 multiplied by 0 and 1, and that will be equal to 2. The third derivative can be found by differentiating the first derivative, which will be equal to d over dx, and then we just need to plug in whatever we had. Now, we just need to write it below here. You never know, we need more space. So the first, this is the same as d over dx of 2x plus, now I may have to apply product rule here, so that will be 2y d over dx. I can see this clearly. So 2y d over dx of dy over dx plus dy over dx multiplied by d over dx of 2y. All right, so what we shall end up with is 2 um, plus 2y d2y over dx2 plus dy over dx multiplied by, now what we shall end up inside this bracket will be 2 dy over dx. Now remember what I did here? I applied product rule. All right, to end up with that. Anyway, so I want you to pay attention to this, guys. This is dy over dx. This is dy over dx. So, I mean, if I multiply those two, I'll end up dy over dx squared. All right, very important. So what I'll end up with here is 2 plus 2y d2y over dx2 plus 2 in bracket dy over dx squared. So this is what the third derivative is. So if I want to find the third derivative at x is equals to 1 and y is equals to 0, then that will be equal to 2 plus 2 multiplied by y is 0. The second derivative was 2 plus 2. Now the first derivative was 1, and then we square that. Now this will give us 2 plus 2, which is 4. Now, so f3 at 1 is equals to 4. Now, we have this bit, which is that. We have, so that's the third. Second derivative. These are our coefficients, all right? So these are our coefficients. These are our coefficients. These are the guys that we need. So if we plug them back here, right? So that will be our step 2. So step 2 will be substitute the coefficients into the expansion. Now, if we substitute the coefficients into the expansion, we'll end up with f of x should be 0 plus x minus 1 multiplied by 1 plus x minus 1 squared over 2 factorial multiplied by 2 plus x minus 3 factorial 4, which is here. So what we shall end up with is, I think that's just about it. Goes up to infinity anyway. If we simplify this, this will be x minus 1 plus x minus 1 squared plus 4 over 3 factorial is 6, x minus 1 cubed plus whatever come next. We can simplify this to x minus 1 plus x minus 1 squared plus 2 over 3 into x minus 1 cubed. All right. So step 3, what was step 3. Yeah, step 3. Step 3, find the approximation. Find the approximation for f 1.1, because I think they've asked us to find y 1.1. Actually, let me write it as y 1.1 because it's a. All right. Okay. So what I'm going to do is to plug 1.1 in place of x. So basically, what I'm going to do is this will be equal to 1.1 minus 1 plus 1.1 minus 1 squared plus 2 over 3 into 1.1 minus 1 cubed plus whatever comes next. So I've just substituted that in place of x to find what the corresponding value of y will be. So what I'll end up with here is if you plug that in your calculator, you should be able to end up with 0.1107.